Hello everyone. In this example, we are asked to find the exact value of cosine of pi over 12, or in other words, cosine of 15 degrees, depending on which unit we want to work with. So pi over 12 is not one of those known angles on our unit circle, but we can express pi over 12 in terms of those known angles on our unit circle, or in other words, we'll be able to express pi over 12 as a sum or difference of some known angles. And once we can do that, we can use our sum and difference formula for cosine to write it in terms of sine and cosine of some known angles. The first step, though, is expressing pi over 12 in terms of some known angles. That's a common theme for some of these problems when we're trying to find the exact value of a trig function at a new angle using a sum and difference formula. For degrees, it's pretty straightforward. Like for 15 degrees, we could think of that as 45 degrees minus 30 degrees gives us 15 degrees, and there we go. But I found in my experience that students have a bit harder time doing that when it involves fractions and radians. So here's my tip for doing it with radians, and it starts by expressing everything using a common denominator, the one given. And so now what we have to do is express pi over 12 as a sum or difference of two fractions, and these two fractions are going to have to simplify to the fractions or angles on our unit circle. So that means they're both going to have some factor of pi. And we could try to do this through addition, but because pi over 12 or 1/12 is pretty small, we'll probably recognize pretty quickly that we have to do this through subtraction or through a difference. And so now what we can do is just kind of plug in some numbers that'll give us a difference corresponding to this numerator, a difference of 1. And so we could do like 2 minus 1. So 2 minus 1 would give us 2 pi over 12 minus 1 pi over 12. 2 pi over 12 would simplify to pi over 6, which is nice, but we'd be stuck with another pi over 12, which we don't know sine and cosine of, so that won't work. We could try 3 pi over 12 minus 2 pi over 12, and that looks like it'll actually work out. Because now when we reduce that fraction, what does 3 pi over 12 reduce to? It reduces to pi over 4. Similarly, 2 pi over 12 will reduce to pi over 6. This is not the only combination we could have used, but we only need to find one combination in order to use our sum and difference formulas. So what this is setting us up for is to use the difference formula for our cosine function. We can see now that cosine of pi over 12 is the same thing as cosine of pi over 4 minus pi over 6. And now that we see it as cosine of a difference of two angles, it'll be a little bit easier to use our difference formula for our cosine function. So we have a difference between our two angles, which means we're going to have to use our difference formula for our cosine function, which has the sum of the two terms on our right-hand side. A is going to be equal to pi over 4 when we plug things into our formula up here, and B is our second angle, the one we are subtracting, which will be pi over 6. All right, so according to our difference formula for our cosine function, cosine of pi over 12 in terms of pi over 4 and pi over 6 is going to be cosine of pi over 4, or our angle A, multiplied by cosine of pi over 6, or our angle B. Then we have to add to that. Remember, the minus on the left-hand side corresponds to a plus on the right-hand side. So we have to add to that sine of our angle A, that is sine of pi over 4, multiplied by sine of our angle B, or sine of pi over 6. And so now to finish this off, we just need to evaluate each of these four pieces on the right-hand side, all of which correspond to known angles and points on our unit circle. Remember, cosine gives us an x-coordinate, sine gives us a y-coordinate. So at the angle or arc length of pi over 4, cosine is going to correspond to square root of 2 over 2. At pi over 6, cosine will be equal to square root of 3 over 2. We have to add to that sine of pi over 4, which is another square root of 2 over 2. That sine of pi over 4 is multiplied by sine of pi over 6, and sine of pi over 6 is going to be equal to 1/2. So now we can simplify this a little bit more. Just multiplying these square roots together, we get the square root of 6 over 4 plus the square root of 2 over 4. Or I guess we could write that as the square root of 6 plus the square root of 2 all over 4. That is our exact value of cosine of pi over 12.